the Winter Examination 2022 paper of Database Management System. So these are the questions we will cover in the video. Why would you choose a database system instead of simple storing data in file processing system? Compare file processing system and DBMS. The file system does not allow sharing of data and sharing is too complex, whereas in DBMS, data can be shared easily due to a centralized system. Data concurrency. Concurrent access to data means more than one user can access the same data at the same time. DBMS centralized data storage, making data management more efficient and structured. Complexity. This is a difference between file system and DBMS. Complexity. File system is less complex, DBMS is more complex. Cost. File system is less expensive, DBMS is more expensive. Attribute. To access data in a file, user requires attributes such as file name or file location. DBMS, no such attributes are required. User access. Only one user can access data at a time in file system. Multiple users can access data at same time in DBMS. Data independency. There is no data independency in file system. Logical and physical data independency is there in DBMS. Example C++, and in DBMS Oracle and SQL services. Define an entity and attribute. Explain the different types of attributes that occur in an ER diagram model with example. Entity. Entity is a real world object. Attribute. Entities are described in a database by a set of attributes. A column can also call attributes. Type of attributes. First, simple attribute. An attribute that cannot be further divided into subparts is known as simple attribute. Example, the roll number of the student. Composite attribute. An attribute that can be split into components is a composite attribute. Example, the address can be further divided into house number, street number, city, state, country, pin code, etc. The name also can be divided into three parts like first name, middle name, last name. Third is single valued attribute. The attribute which take up an only single value for each instance is known as single valued attribute. Example, the age of student. Multi-valued attribute. The attribute which takes up more than a single value for each entity instance is a multi-valued attribute. Example, phone number of a student, landline number or mobile number. Complex attribute. Those attributes which can be formed by the nesting of composite and multi-valued attribute. Derived attribute. An attribute that can be divided from other attributes is derived attribute. Example, total and average marks of a student. Stored attribute. The stored attribute are those attributes which doesn't require any type of update since they are stored in the database. Example, date of birth is stored attribute. Key attribute. Key attributes are those attributes that can uniquely identify the entity in the entity set. Example, roll number is the key attribute because it can uniquely identify the student. Next question, draw an ER diagram of banking system taking into account at least 5 entities, indicate all keys, constraints and assumptions that are made. So this is the ER diagram. Question 2, solve any two of the following. First, define and differentiate the following algebra operations with suitable example. Cartesian product and natural join. Cartesian product. The Cartesian product operation denoted by X allows us to combine information from any two relations. For example, the relations schema for R is given below. Natural join. Natural join is a binary operation that allows us to combine certain selection. It is denoted by this symbol, and this is the example is given below. Difference between natural join and Cartesian product. Natural join joins two tables based on same natural join joins two tables based on same attribute, name and data type. And Cartesian product, it will produce cross product of two tables. In natural join, the resulting table will contain all the attributes of both the tables but keep only one copy of each column. In Cartesian product, the resulting table will contain all the attribute of both the tables including duplicate column also. In natural join, if there is no condition specifies, then it returns the rows based on the common columns. In Cartesian product, no condition specifies them. It returns all possible pairing of rows from both tables, whether matched or not. We consider the following relation schema. Write a relational algebra query to find the name of suppliers who supply some red parts. This is the algebra query. What is view? What are its advantages? Explain view in SQL with the suitable example. To define a view, we must give the view a name. Must state the query that computes the view. Example, create view all customer at select branch name, customer name from depositor account, where depositor account number account slash number. Union query. Definition of view: result set of stored query which can be queried in the same manner as a persistence database collection object. Advantages of view: view can represent a subset of the data contained in a table. View can join and simplify multiple tables into a single virtual tables. View can act as aggregated tables where the database engine aggregates data, sum, average, etc., and presents the calculated results as part of the data. View can hide the complexity of data. View take a very little space to store. The database contains only the definition of a view, not a copy of all the data that it presents. Structures data in a way that classes of users find. What is normalization? Explain the importance of normalization. What is the criteria for good relational design? Normalization. Normalization is a process of reducing the data redundancy in a table and improving data integrity. Normalization is a technique for organizing data in database. Importance of normalization. It is important that a database is normalized to minimize redundancy, means duplicate data, and ensure only related data is stored in each table. It eliminates redundant data. It reduces chance of data error. The normalization is important because it allows database to take up less disk space. It also helps in increasing the performance of the database. It improves data integrity and consistency. Explain BCNF and suitable example and distinguish between BCNF and 3NF. BCNF means voice code normal form. In database management system, an advanced version of 3NF. A table or relation is said to be in BCNF in DBMS if the table or the relation is already in 3NF, and also for every functional dependency says X to Y, and X is either the super key or the candidate key. This is the example given below. Difference between 3NF and BCNF. 3NF is the first column, and in the second column there is a BCNF. 3NF stands for third normal form. BCNF stands for Boy's Code normal form. In 3NF there should be no transitive dependency. This is non-prime attribute should be transitively dependent on candidate key. In BCNF, for any relation A to B, A should be a super key of relation. It is less stronger than BCNF. It is comparatively more stronger than 3NF. In 3NF, the functional dependencies are already in 1NF and 2NF, and in BCNF, the functional dependency are already in 1NF, 2NF, and 3NF. The redundancy is high in 3NF. The redundancy is low in BCNF. It is easier to achieve. It is difficult to achieve. 3NF can be obtained without sacrificing all dependencies. Dependencies may not be preserved in BCNF. Lossless decomposition can be achieved by 3NF. Lossless decomposition is hard to achieve in the BCNF. Consider the relation schema R equal to A, B, C, G, H, I, and set of the functional dependencies. This is the answer. Explain acid properties in detail. Acid properties. A stands for atomicity, C for consistency, I for isolation, D for atomicity. By this we can mean that either the entire transaction takes place at once or doesn't happen at all. There is no midway, that transactions do not occur partially. Each transition is considered as one unit and either runs to completion or is not executed at all. It involves two operations, abort and commit. Abort: if a transaction aborts, changes made to the databases are not visible. Commit: if a transaction commits, changes made to the database are visible. Consider the following transaction: T consistent T1 and T2, transfer of 100 is the example of atomicity. Consistency: this means that integrity constraints must be maintained so that the database is consistent before and after the transaction. The refers to the correctness of database. This is the example given below. Isolation: this property ensures that multiple transactions can occur concurrently without leading to the inconsistency of the database state. Transactions occur independently without interference. Change occur particular transaction will not be visible to any other transaction is returned to memory or has been committed. The result in the database inconsistency due to loss of 50 units, hence transaction must take place in isolation and changes should be visible only. So this is the example. Durability: this property ensures that once the transaction has completed execution, the updates and modifications in the database are stored and returned to the disk, and they persist even if a system failure occurs. These updates now become permanent and are stored in non-volatile memory. These effects of the transaction that are in never lost. These are some important points. Atomicity transaction manager, consistency application programmer, isolation concurrency control manager, durability recovery manager. What is are ordered indices? Explain with suitable example. Distinguish between dense index and sparse matrix. So what is order indices? The indices are usually stored to make searching faster. The indices which are stored are known as ordered indices. Example: suppose we have an employee table with thousands of records and of which 10 bytes long. If their ID starts with 1, 2 or 3 and so on, we have search student with ID 543. In the case of database with no index, we have searched the disk block from the starting till it reaches 554, the DBMS will read the after reading 543 into 10 equal to 5430 byte. So this is the difference between dense index and sparse index. Index size larger, smaller. Record in data file need not be clustered, need to be clustered. Time to locate a data less, more. Computing time in RAM less, more. Overhead for insertion and deletion more, less. Data pointers pointing to each record in the data file, fewer records in the data file.